Okay, so we have looked at the functions, how to declare them, okay, how to define them, and how to use them. So we define them by defining what they are supposed to be doing, and then to see what they are doing, we call them and we provide some actual values that could stand for the parameters that we define the function with. And if you look at the way we are calling the functions, we are providing some arbitrary values. You can say static values, okay? Just values that we provide offhand, okay? But some other times, or even most of the times, like in database environment, we find ourselves whereby the values that we are going to provide as parameters to the function, they are going to be values from a table, okay? So for example, when you have like the date of birth, you may find that this date of birth value is not going to be provided just like we did here. Rather, it is going to be a value that is going to come from a table column within our database. So for example, we have members here, and on members, we have a column for date birth. So maybe you want to return a list of members, maybe with their first name, last name, and gender. In addition to this, we want also to return their age. Okay, so since we don't have age here, we only have date of birth, we can easily use our function compute age to compute the value of each member depending on the date value that the member has. Let us see that. Okay, so you can see that still here it is like treated as one full query, because when you start using these delimiters, we always have to indicate that we are ending the delimiter, otherwise to always continue with the same query. So for me to write a separate query down here, I need to say end this. Okay, so now it has isolated that one. Then I can write my individual query down here. So maybe I want to return a list of members. Okay, so like I want to say select, I want to say first name and then last name, then gender, and then after gender we want to return the age of the value. So instead of writing the computation within my query, like the computation that we wrote up here, okay, within the function, we could have written the same function here, but because now it is already in the function, you don't have to write the computation to compute age. Rather, I can just call my function that computes the age right here, and I provide the column that has the date values that will be passed as parameters to my function. Okay, so I could do something like I'm going to call my function fn compute age. So this is the function that I'm calling, which computes compute age, and since it has one parameter for birth date, okay, so I can provide the column that I have for my column date of birth and on members table as a value, or as an argument to my compute age value, I mean function. So I can just pass in date of birth. So why are we passing date of birth here? Because this is a column that within this table has values of date of birth of all members. Let us see here. So I'm going to first of all select start from members. Okay, I always have to put this to isolate it. So I want to execute only this. So it is happening. Okay. Okay, just a moment. Maybe the problem with using these delimiters, they confuse sometimes. So when I run, you can see that this column date of birth has date of birth values for all the members. So when I write this query here and I call my compute age function and I pass in this column, it is going to be picking the date value of each of the members, and it uses that value to compute the age value of that particular member. So to first pick this value for this member Jones, so it will compute the age of John using this date that is passed here. And then to go to the next member, it will pass in this date, and then to compute the age of that person, likewise the rest of the members. So instead of passing a static value like we did here, we are rather saying that, okay, pick the date values from a column named as date of birth from our table named as members. So here we have to go ahead and say from members, because we need to tell the source of the columns that we are putting. So I can just say here as age. Okay, so now execute this. First name, I made a spelling mistake here. So I get my columns returned and the age of each member depending on their year of birth or date of birth. So here, one of the benefits, we said one of the benefits of functions is it helps us to okay, it facilitates for code reuse. Okay, it helps us to achieve the functionality of code reuse, whereby we are using the same function to compute age of all the members, and maybe we could be having some other tables where we could also be maybe the data. Maybe we have a list of employees. We have a table for employees, which type of employees also has date of birth for the employee. So you can use the same function both to compute the age of members and also to compute the age of employees without rewriting our code. We are just reusing the same code snippet to do the functionality for us. So we can also, as we have seen this one, compute amount. You can also apply it to one of the tables. If you look at our cells, okay, let me just write this thing of what of delimiters is disturbing me a lot. Anyway, let me just put and then, so when I write select star from cells, so you can see that we have a list of cells that have the quantity and the unit price. So we may be interested that we want to list the list of cells for the movies, and we have a column for amount, which is going to be a result of multiplying the quantity and the unit price. So you can easily use our compute amount function to compute the amount of each of the sales records within our sales table. So how do we do that? Let me first end this. Why am I doing this? Because I initiated this delimiter thing. So for each query that I have to write, I have to end the delimiter. So it keeps on tracking those things. So that's why I keep on putting this so that I can isolate these queries from the others. Okay, so we want to return a list of sales records, but with the computation of the amount. Okay, so maybe I want to say select, have the sales date, okay, and then the movie ID, and then okay, we also need the quantity. We also have the unit price. So in addition to this, we need to add a computation for amount. So instead of writing here quantity times unit price, I already have this functionality already somewhere within the function that I can just call, and it gives me the computation here. So instead of saying here quantity times the unit price, okay, to give me the amount, I don't need to do this. I can just call my function, which is fn compute amount, and then as parameters, because this function takes two parameters, it takes the quantity and the unit price. So I can just pass in the column names of quantity and unit price. So it will keep on getting the values of each row as it passes it to the function, and then it uses those values to compute, meaning that for the first record, it will take 5 for quantity and 1,500 for amount. So it gives us the amount for that. In the second record, it will take the 2 as quantity and then 1,000 as the unit price, and then it multiplies it to get to give us the amount. So I just have to pass in the column names, quantity, and then so what I'm passing in here as quantity is the column name that I have here, which has the values for quantity, and then unit price is this column that has the unit price values for our cells, and I can just return it as amount. And since we have columns, so since we have columns here, so we have to provide a source of these columns, which is the table cells. Otherwise, when we are executing these functions here, we didn't have any column value, so we didn't have to put the from clause. We could just say from duo. But here, since we have columns from a particular table, it is a must to indicate the source. So when I do that, using my function, it gives me the computed values of each cell's record without the need of rewriting the formula to compute the amount. So meaning that I can reuse this function anywhere I need to perform any computation of quantity and unit price. So that is some of the few things that you can add onto functions. Okay, then I still have a few minutes to end of this recording. So the other thing that we can look at, okay, before we can look at the other thing, you can see that I get issues with the delimiter, so I have to always end the symbol. So there is an easier way to work with functions instead of just writing them within this text editor here, because you can see that I have these functions written within this text editor. So it is the one that is causing those issues when you're trying to execute individual queries. So you can have a better way that we don't write them in here, we just get their separate editor, and you only have a function on its own within that editor. So when you right click within after selecting the database, so when you right click, we have here an option for create new procedure or function. So when I click on it, all I need to do is to provide the function name. Okay, all I need is to provide a function name. So maybe within this function, I want to say I want to compute the profit. So function compute profit. So I just provide the function name, and take note there are two buttons. One is for procedure and another one is for function. So you have to be careful not just to press enter, because if you press enter, it is this active button that will be activated, yet you need to create a function. So you have to take note and you use your mouse to select the right button depending on what you're creating. So I click on create function. So when I do that, it will open up a tab that only has the code for only this function. So I have my results set up here, which I can use to execute my individual queries and also maybe to call the function. But the code for the function is written here in its own tab, and I can just close it when I'm done. I can open it every time I need. So the same thing like with these functions that I already have. So I can right click here and I say edit function. So when I do that, it will open up in its own tab, and then I can be able to see whatever I have there. I can make changes after I execute to add these changes, and then I can close it when I'm done. So this is I find it a better way to work with functions and procedures and triggers, so that I don't have these issues within here. So I can easily remove these functions statements here, so that here I just maintain my individual queries that I want to execute. So I don't have to worry about the ends and the whats. Okay. So I just have my clean editor, just like we had it before. Okay. So Okay, now this is what we can do. So it gives you the snippet for the structure of creating a function, which we have here, create function, and then this is the function name that you gave in the dialog box that came up, and then the returns. So by default it gives you int, but you just have to come here and change it to whatever return type that you expect. It ends for you, and all you need to do is just to put the cursor here and you start writing your codes. So it adds some other few things. It has this line that we didn't look at initially. So what this line indicates is it says drop function if exists. It is plain English. Drop this function if it exists. That is, if you're trying to create a function which has the same name as function fn compute profit, it is already existing, and yet you're trying to create the same function, first drop it and then recreate it. This happens when you make changes to the function and you want to apply those changes to the function. So every time you use the create, if you don't have this line, it will always throw an error. This function already exists. So to avoid such an error, we use this line. Drop the function first, and then you try to create it with the new changes that we have added. So we are going to proceed in the next tutorial, just to make this recording shorter.